Yeah. Hello, I'm Marek Marczykowski-Górecki from Invisible Things Lab. I'm doing open source for quite some time already, and I'm project leader of CubesOS, which is one of the products using Xen. So today I'm going to talk about uh, some secure boot and unified kernel image with Xen. So why secure boot? So the idea is that the firmware will boot only kernel bootloader binaries that are assigned with authorized keys. And most x86 systems ships with some authorized keys predefined, keys belonging to Microsoft. And Microsoft also has a key to sign third-party operating systems, not only Windows. And Microsoft also set some requirements what that operating system needs to do to be signed. So basically, the short story is Microsoft wants all the kernel level code to be to be protected, to be to system only run authorized kernel code. So in case of Linux, that means the main binary and modules. And also it means disabling a bunch of APIs that allow to modify kernel code. But with Linux, it gets more complicated. So back to Linux. So generally, the rules by Microsoft are modeled after Windows. So it fits pretty well with Windows threat model. With Linux is also mostly compatible because it's focusing on monolithic systems. So you have one kernel, maybe with some extensions on modules, but basically you have clear separation what is the kernel code and what is the user code. And especially in Windows, also the kernel code is much more privileged than user code, even if that user is administrator. With Linux, root user on Linux can do a lot. Normally, you can access devmem, and if you pass some extra parameter, you can modify basically any memory. So it's the isolation between root and the kernel is much weaker in standard Linux. And also, there is a much more configuration option that you can pass to Linux to do some stuff. So with Windows, you also have some kernel options you can set, but they most of them doesn't allow you to bypass any security mechanism. With Linux, you can disable maybe not everything, but most of this using kernel command lines. So how Linux do secure boot? Basically, they introduce something like lockdown mode, which if it detects secure boot is active, then it disables a lot of configuration options, a lot of APIs, and the hope is they got everything locked down. Sometimes not. But it's only about kernel. With Linux, we have also something like initramfs, which is not part of the kernel, but it's responsible for load kernel modules to mount root file system, and especially with encrypted disks. It also handles the disk password and unlocks the disk. So it has a pretty important role in boot integrity. But according to Microsoft rules, it doesn't need to be protected with any signature in secure boot, which makes it easier for Linux distributions, but it's not a great thing for actual boot integrity. With Xen, we have a bunch of other extra challenges. So, of course, Xen also has a bunch of boot options that can disable some security mechanisms. For example, you can easily disable IOMMU with a single option, which is not great for security. And also we have DOM0, which inherits all the issues that with Linux. So all the kernel options and similar with initRD, which I did not include in this slide. With Linux on Xen, there is a bunch of extra steps. One is about privcmd device, which is very helpful in DOM0. It allows you to do arbitrary hypercall. But it also means whoever has access to this device can pretty much do anything with any domain, including DOM0 itself. Yeah, so doing properly secure boot on Xen is extra challenging. And DOM0, even if we manage to fully protect DOM0 kernel and maybe some user space, still DOM0 can do anything with DOMU, including accessing its memory, modifying memory. Some of that is strictly needed to be able to start any DOMU, and that's the role of DOM0 here. So we cannot really lock it down. But with proper secure boot and maybe encrypted VMs that support attestation, maybe it could be protected. Okay, so that's about generic approach. In kubes.os, what we'd like to get with secure boot. So yeah, kubes.os does not currently support secure boot. And we'd like to make two things. First, to make it eligible for Microsoft signing. This is mostly for, well, I would say convenience for users, because currently if you want to install kubes.os, they're very much security-focused operating system, then the first thing you need to do is to go to your firmware settings and disable feature misnamed as secure boot. So that's technically not a big thing, but some, especially management in some companies is very not happy about this, and they have some compliance rules that secure boot needs to be enabled, etc. So that's a problem. And the other thing, to actually, when we do all this work, we'd like secure boot to actually provide some security value, not just be yet another check mark. A little digression: when you boot Xen, you have two boot protocols. I focus on UEFI systems here. There is also legacy boot, which uses only multi-boot 2. But with UEFI, we have two ways. There is multi-boot 2 with UEFI extension, and there is a Xen.EFI binary, which is using native UEFI boot protocol. So with multi-boot, it gets support for loading extra binaries, especially for DOM0 kernel and initramfs built in the protocol. That's why the name multi-boot, because you can boot many things. But with XenFI, it loads just a single binary. So Xen needs some way to load DOM0, initramfs, maybe something else, maybe some microcode updates. So the standard approach is to provide a config file in the same directory as the binary. That config file specifies file names that needs to be loaded, and then goes to firmware and asks, hey, load this extra file from the same place that the binary was. So that works if your firmware is not buggy. And also if your bootloader is not doing something crazy. If you use Grub, Grub is very powerful bootloader. It can, for example, support multiple file systems, even if your firmware doesn't. So, for example, you can load your kernel from Lux encrypted partition using Grub. That works, but if Xen goes to the firmware and asks for extra files to load, firmware has no idea about that Lux encrypted partition. Similar for other file systems. So this breaks in practice in many cases. So now to the main topic. So unified image. That's Xen.EFI binary that has extra sections with DOM0 kernel, maybe JAMFS, maybe config options like command line, all embedded in one binary. Yeah, we can also include options both for Xen and for DOM0. And all of that is in a single UEFI binary, and you can find this binary, which means you get implicitly all of that protected by any malicious modifications. So you don't need to worry anymore about whether some option is dangerous or not. You can lock down the command line for both kernel and Xen. This is all nice. Of course, there are some practical issues that, like you need some maybe some machine-specific options for a kernel, so you cannot have a binary with embedded options that works everywhere. So it's not a perfect solution yet. We have some ideas how to do that later on that. So how to do that? So first you start with normal build process. Then you use object copy to add extra section, .config, kernel, RAM disk, ucode, XSM. I think there is one more for device tree possible, but that's basically it. There is the config one. It's the config for Xen, similar as with standalone XenFI. It's mostly for boot options. The file names, what to load if you get kernel, DOM0 kernel RAM disk embedded, gets ignored. But the options are used from the config. And you can decide what you want to embed. You don't need to embed everything. If you, for example, embed only kernel and not the RAM disk, you can still load, if your config specify that, you can still load the RAM disk from some separate file. And you can decide what's embedded in the one binary protected by a common signature and what is separate. There is some official documentation for that. It's a bit outdated, but it's just some minor details. I think the pad section is gone, so you need the method to find what the address for extra section needs to be different. But there is also a script UKI generate which does everything of that automatically. So you just provide list of files and it produces the final binary. And then you can use the standard Secure Boot tools to sign it, SBSign, for example. So you get a single binary. You can be sure that with given Xen version, matching DOM0 kernel, version is loaded. That's great for deploying security fixes, so you don't need to like track both things separately. You have one. You can protect extra things, not just the DOM0, not just the Xen binary with signature, but also kernel and initramfs and command lines. Xen does have option to verify DOM0 kernel signature. Does have support for that for Secure Boot, but you still need to worry about initramfs if you want to protect it. Yeah, and also at the same time get rid of the issue of loading extra files via firmware, so you can use whatever bootloader you want to load one binary, and then it doesn't need to talk to the firmware for extra files anymore. Yeah. So what about those boot options? So currently you can decide to hardcode all of them or not, and then user have flexibility in setting those options. Then does have the lockdown option to lockdown mode to support to disable some of the most dangerous options. So yeah. What I would like to get at some point is the config that is embedded in the signed binary to not only have some basic options that are set, but also to have allow list what options user can provide to the both Xen and DOM0 kernel. So instead of hard coding all the options, some options from the user would be allowed. I think I would focus only on option names and not the values. So if you need something that needs some verification of also the value, that's getting out of scope here. But that would allow, for example, specifying root file system for DOM0 and not it to be hard coded in the options. And yeah, that's some flexibility we need. And generally, the goal of this is to have strong secure boot and provide some more value with all the work done in that direction than Microsoft thinks will work. Because Linux and Xen are not exactly the same as Windows. Yeah, and I have one extra slide. If somebody wants to test it, you can test it on physical machine, but you can also do that on QEMU. If you install QEMU on Debian, it provides also specifically OVMF package on Debian, includes also files with test key for this snake key for secure boot, and you get a private key for that in a separate package. So you can create, you can start QEMU VM with secure boot, but with your own key easily. It's also possible to do that manually, but that's several steps less to do manually. And I also highly recommend for testing UEFI boot using drive file FAT, because you don't need to prepare disk image. You can just take a directory and get the boot ESP partition out of the directory. Again, one step less when testing. And there is an issue on the Kube's backtracker with a description of the whole test procedure, how to build things, how to sign a unified image, and how to start the VM. So that's it. Any questions?
Any questions? We have time for about two.
Thank you. Thanks for the presentation. I was wondering, how is SBAP managed in the use case situation, how do you manage populating the SBAT entries?
Yeah, so there is not much difference technically. You still need to provide this file, and if you embed the Linux kernel, you still that Linux kernel will have its own SBAT embedded, and then Xen will have own SBAT embedded. Currently, we didn't touch this issue. So the outside binary will see only the SBAT from the Xen binary. So the SBAT from Linux will be kind of hidden. That's actually a very good point. We probably should copy entries to the unified binary SBAT.
You can probably merge all of the SBATs together, right?
Yeah, exactly. Yeah, that's a very good point.
How about loading kernel modules? Is there support for that, or is it totally forbidden?
Yeah, loading kernel modules works fine because the Linux, when you build Linux, by default you get a random key generated during build process, and it's embedded in the kernel binary, and modules built together with that kernel are signed with the same key. So kernel can load modules during build with the same build process. Yeah.
Right. So in your security model, loading modules that are built along with the kernel is acceptable.
Yes. Yeah.
Right. Thanks.
You can configure Linux to not allow modules if you like. That's up to your Linux configuration. But yeah.